Okay. Morning, ladies and gentlemen. Welcome to Informatics 1B. Again, we're going into recursion. Just two or three announcements as I remember them. One, please, those on Discord, make sure your nickname is your student number. If you got in, because I know some of you may use your Discord for gaming and that we don't mind, but just make sure your nickname on the Informatics 1B Discord server is your student number, as long as the assistance lab is your student number. It just makes things a bit easier for everyone involved. So what is going to happen today is if you haven't changed your nickname, we are going to kick you from the server and you can rejoin with your student number, please. It's just that we want to keep the system, the Discord server quite professional in terms of the purpose of it. Other things to keep in mind, please book. Some of you haven't booked your practical sessions. I did send out an announcement on Blackboard. I emailed you guys yesterday just to remind you, as a lot of students haven't booked, so I'm a bit concerned there. So make sure you've booked, because today I'm going to start allocating you into your respective groups. Groups from 1 to 21, and then those will be your marking groups for most of the semester. I want to make sure everyone gets the distribution is fairly done, so you have time to ask your assistant for feedback. On that note, I'm getting a lot of messages, do we have to attend? Look, if you don't have a lot of data, we're not going to force you to attend the online session, but it will help you to get feedback on the practical if you can attend. So you can go on and get feedback from your assistants directly. Okay, so that allows you to get some feedback on your practicals, what you're doing right, what you're doing wrong. We're going to have a comment on your mark sheet that will also show just a very small comment. The assistants can write in if you did something wrong, but that's limited in space, so it can't be a long comment. We're looking at other ways of distributing feedback. We'll keep you informed about that. What other announcements? Practicals tomorrow. By the end of the day, you'll know your session and group. So please just check that, connect to the Discord server for if you want to get feedback. Marking will be first, I think first come, first serve on the thing per session. Don't come to session 1 if you're session 2. Okay, so if you come into the server and the assistants, okay, and that I want to let you know now. Some of the assistants also are battling with data, so they may not be live for the feedback. We are working on a way to give you guys feedback regardless. Just give us a bit of time to sort something out there. But the assistants that are online will be able to give you feedback. I do know of some assistants that don't have enough data to do live voice chats. Just like some of you guys some of the other students battle to connect to the live lectures. Same thing goes. The assistants are also the assistants and tutors are also students. Remember that, so they don't have an infinite amount of data. So we will work around that as much as we can. Okay, yeah. So those who aren't reading the chat, we are going to go through a bit of the. We'll do prac-related questions in the tutorial this afternoon, so we don't waste much more time here. That's a Discord server. That's a practical tomorrow. That's the bookings. I think that's about it for the announcements. Any questions about recursion? Because that's the main thing we're focusing on today. Is everyone okay with the theory that we did yesterday? Okay. 90%. Okay. Okay. I do appreciate the comments from you gentlemen and ladies. Just if the other students as well. Okay, that's one thing. Some of you students are grasping it better, some aren't. So let's just go through the slides quickly and then I'll show you some implementation. So is everyone okay that recursion is the ability for a function to call itself? Is everyone okay at that point? Okay, good. Now, everyone, firstly, that's the wrong way to do it. The right way to do it is to have a base case. This tells the function when to stop. Okay, the base case tells the function when to stop, and that's the most important thing. Also note that next week, Tuesday's tutorials will be focused on recursion. So this is more of the theory. We'll do a bit more practical in next week's tutorials. So this is just to get you the introduction, and we'll do a bit more practicals in the tutorial to get you guys a bit more clarity. But what I need to get from you guys today is that you understand a base case and a recursive call. And then I'm going to work through Fibonacci and the factorial, working out both recursively and iteratively. So you can see how different they are. And you can actually see where recursion is a lot more applicable in comparison to loops. Indirect and direct I'll explain today. I'll explain this. And these two slides are more about just general knowledge of when to use which one. So why recursion? Okay, is everyone okay with the Fibonacci sequence? Oh, sorry, let's start with factorial. Factorial is the more interesting one. Fibonacci we'll get to. Fibonacci we will get to. So factorial, let me just, okay, is that, let me zoom in a bit more and hide that away, hide that away. So factorial is the sequence. Okay, I'm going to jump around a bit. Is this lovely n times n minus 1 plus n times n minus 2 times all the way down to 1. So factorial, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Okay, so if we've got to do this in a iterative way, say a while loop. So we're going to have a private function, fact iterative, fact loop, and we give it a value, an n. Okay, that's its ending point as integer. Now I'm going to do this using a loop. So we need to start with a sum. Now this value of sum here, let me pose the question of this. Sum equals what? What should sum start at, looking at the sequence we have? Any ideas, ladies and gentlemen? What should sum start at? Okay, let's change this sequence, so make it a bit more avoid the 5, because I don't want you guys thinking that there's always going to be a 5. And only one person got it right. 1. Sum will start at 1. Okay, we got to work towards 1. We don't know what n is going to be. Okay, you probably could start at n. Let's see. Let us actually do a bit of experimentation this morning and see. That's the only way we're going to learn. I'm going to start at 1 for the first one, then we'll start at n in another one. So firstly, if n is less than n is 1, then return 1. Everyone okay with that? So if we have value of n being 1, we return 1, because 1 times 1 is 1. You guys okay with that point? Okay, cool. Now we say while n is greater than 1, sum equals sum times n. Every time we loop, we go n equals n minus 1. Okay, and we return sum. Okay, so that's factorial being done with a loop. So if n is, okay, with a return statement, if n is 1, the function will stop here. If n is anything else, it will stop here. So there's two possibilities of exiting the loop. So if we give it 1, it will then exit at whichever value, between it's 1 or n. Yes, you can do that. I just did it because you can do this. As well. Okay. So you guys okay with that? How I have solved it using a iterative approach. This could also be done in a for loop. We could do this for n equals for value equal as integer equals n to 1 step minus 1 value next, and that should technically give us the same result. Okay, factorial can't handle negatives. And I'd actually wait. Let's test. I mean, just go and Google. Okay. If we go negative, it can't be a decimal. Factorial doesn't exist within decimal ranges. If we go negative, it's just a negative reverse. So a negative 5 factorial is actually equal to negative times 5 factorial. So you would actually work out 5 factorial and then make it negative. And can n be decimal? No. Factorials do not work with decimals. Factorials only work with value of n, or a whole value. Now let's look at the recursive approach, which I find a hell of a lot easier. Private function, or it looks simpler, put it that way. Factorial, recursive, n as integer, as integer. Now, what do we need for a function? What am I missing? N. As. What two things build up a recursive function? What two things do we have to make recursive functions? We've just mentioned a few minutes ago. Base case, good. And recursive call, fantastic. So we need our base case. Our base case says, when does it stop? So if n equals 1, then we return 1. Else, we return n times the function n minus 1. That's it. That is factorial in recursion. Okay, recursion is especially useful for mathematical problems and mathematical equations. It takes an extremely complicated mathematical system and breaks it down to a very simple form. I'll show you what type of questions will be asked in semester test. Remember yesterday I explained how it stacks on top of each other? It will return one it'll return the right answer. So how to draw this out properly. Oh wait, I've forgotten the important thing on the code here. In this case, base case will always be run, one, because of the fact that we are using the factorial. The base case has to be 1 because we know that's the endpoint. Let me show you something else. I don't remember the other way to do this. There is another way to swap the base case around. Oh, that's right. If n is that's another way to write it. The base case doesn't always have to be the first one. Okay. In this case, here's my recursive call. Here's my base case. Okay. But it does make more sense the other way around, to be honest. This is just a simpler variation. It matches the mathematical setup of factorial to a T. So it allows us to work with it quite easily. So while you guys are digesting that one, I'm going to do the Fibonacci. Now, Fibonacci recursively is interesting. Okay. There's various ways to do it. I actually had to go and look for a way to do it. So see, I've got a question in chat. On the recursive call, the n is going to return a number until 1. So it's going to keep returning n, and then n minus 1, n minus 1, n minus 1, until it reaches 1 and then returns 1. I tried to do this yesterday in Paint, but it worked like hell. So I'm going to try to do it in PowerPoint today. Yeah, it tells it when it's going to stop running. The base case tells it when it's going to stop running. So what's happening is this. Let me just go to insert simple art. I don't, no, pictures, shapes. Remember, every time we add onto the stack, we add a value. So if I go and I call this, let me just try to work it out. I'll come back to your chats. Also, I'm going to keep getting distracted. Your questions. If I don't do it, Mr. Van der Westhuizen will answer you as well in chat. I'm going to focus on this right now so I don't jump around and confuse you guys. I'm looking for insert word text. So if I do this, fact recurs 6. Okay. It's this will then, if we look at the question, is 6 equal to 1? Yes or no? Okay. So it doesn't know what the hell 6 is. The function doesn't know what 6 is. It doesn't know an answer. So it needs to find out what is 6. It needs to work to a point of, yes, I have an answer. It knows that it's going to go 6 times fact 6 minus 1. Does it know what 6, or let's just put it at 5. We all know it's 5. Does it know what fact 5 is? Fact recursive 5 is? Does it know what fact 5 is? No. So again, it adds onto the stack and goes 5 times fact recursive 4. Does it know what 4 is? No. So it adds on and goes 4 times fact recurse 3. Now it still doesn't answer that. So it's 4. There's a 3. It's in the 2. It doesn't know what 2 is. So it puts 2 here and a 1 here. Now, does it know what 1 is? Yes, it's 1. So what it now does is goes here and says, fine, let's swap this out for 1. Let's swap this out for 3 times 2 times 1, because we now know what the 2 was. We now know what fact 3 is. Fact 3 is 3 times 2 times 1. We now know what fact 4 is. No. Also, one thing, as we do this, these are removed from the stack. Forgot to mention that. Those are actually removed from the stack. So this will be 4 times 3 times 2 times 1. Now we have the answer for this one. Just removes from the stack, passes back to the final one. And gives us that answer. Now we can finally say that this is equal to 6, uppercase, 6 times. Okay, that's how recursion works. It builds up a stack and then breaks a stack down. Everyone okay with that? Omar, I think you are right, because fact of 1 of 5 is 120. Gift, you got a question? I saw a hand go up. Okay. That's fine, don't stress. We're all getting used to the platform. Does that make sense how recursion is working? It builds up a stack until it knows an answer and then pulls the stack back down. Okay, cool. Let's do the Fibonacci. So fib, first with the loop. And what's that? Fib, loop, and in as integer, equal as integer. And remember, with Fibonacci, I forgot the function. Yeah, you say private function. I made a mistake. Remember, Fibonacci is n equals that's the equation for Fibonacci. Fibonacci of 0 equals 1. Fibonacci of 1 equals 1. Ask me why that's how they decided to define Fibonacci. I don't know the mathematical proof behind it. I just know how it works. Okay, so that's what Fibonacci is. So for a for loop, this is kind of interesting. I had to do a bit of Googling to find a decent one. So if as integer, and we have them I as integer. There's probably an easier way to do this. I'm just going with one way I've found. Hopefully it'll work. No, Fibonacci of 0 is 1. If n is less than 2, we return 1. Wait, I think you might be right. Let's just check. No. Let me not make this stuff up. Just give me a second to double check the sequence. Yeah, you are right. It is 0. Apologies. Okay, so it is 0. So then we return n. Everyone okay with that? So if n is less than 2, we return n. So if n is 0 or 1, it returns n. Else, we need to go and redum f to n minus 1. So we're going to have to resize an array. Okay. Once you've got that, we start working on the basics. And these are, let's look, there might be an easier one online, I don't know. I don't really like doing Fibonacci in a iterative approach. It is rather annoying. I equals 2 to n minus 1. Okay. Then we say fib I is equal to fib I8. The array minus 1 plus f minus 2. Next, it's not f, it's fi. And we then return f minus 1. This looks confusing as hell, correct? It's not a very elegant way to solve Fibonacci. Okay. It is a way to solve it. It'll work, but hell, it's a pain in the ass to program. Contrary, the Fibonacci recursive is so much easier. I'm just going to make my. Oh wait, no, I remember. And f of 2 is Fibonacci. Yeah, that's it. I just want to double check. That's correct. I'm just trying to work out my next step. Because now we're going to do private function Fibo with n as integer, and now we need to do our base case. If n equals 1 or n equals 0, then return n. Okay. Else, this is especially why I like recursion. Recursion here is golden. Okay. This won't have anything to do with tomorrow's practical. This will be Prac 2 going forward. Return Fibbo of n minus 1 plus Fibbo of n minus 2. And that is the Fibonacci recursive. Okay, much more to the point and actually makes sense. Okay, it is a lot easier to understand and work through because of the simplicity, and it's mirroring the maths. The lectures are always uploaded to Eve, but on that note, they're only available for 1 month, and then I'll delete them because I'm saving space on Eve. We can't have all the lectures for the entire semester on Eve. It'll just take up too much space, as there's more than one subject on Eve. Can we do a trace table? We'll do what I did with the factorial in a PowerPoint, and we'll do that. I don't trust the loop either. To be honest, I don't trust it either. We'll be on Blackboard the entire, and we'll be on Blackboard and YouTube the entire. Okay, sorry, jumping back a question. Lectures will be on Blackboard the entire semester and on YouTube the entire semester. Only Eve will be deleted after a month to save space. Ladies and gentlemen, to be honest, I don't trust the this loop. I don't trust it. It just seems wrong in some way. But the problem, what I'm trying to point out is not that this is wrong. I'm talking about the complexity. Which looks easier, the loop or the recursion? Because remember, everything can be solved by using a loop. But certain things fit better for recursion. In this case, Fibonacci factorial are very recursive based questions. These things are solved especially easy with recursion. You can do it with a while loop and a for loop. It just is annoying, but it is a lot easier with recursion. That's why we're teaching you recursion. Recursion also falls in other areas when you're trying to do certain things, but it must lean towards recursion. So let's just quickly do a table on this one's happening. Let's insert shapes. One practical on recursion, and that's it. Okay, well, let me not say one and that's it. There might be one or two, not many. We don't do many on recursion because the main focus of the semester is object-oriented programming and in terms of files. So let's just start with something small. Fib of 6. So fib of 6, if you look at the code, fib of 6 is not 1 or 0. It's going to give us it's going to give us this one. So it's going to give us, and this is where it gets a very, how would I stack this properly? Because it's a dual stack. Sorry, just give me a second to think. I don't think I'd be drawing out these things this morning. Because technically, this would give me fib of 5 and fib of 4. Okay. Then I would get a very messed up stack. I don't know if stacking with a golden ratio would work. We'll try this and then see what happens. Because this would give us fib of 4 plus fib of 3. This side would give us fib of 3 and fib of 2. This would give us another 2. Because remember, for every recursive call you make, you're stacking recursion. So as you see, as I'm going up, I'm stacking multiples. I can separate the 2 and then come back. That's a good idea. So we know it's fib of 5 plus fib of 4. Everyone go with that. So we're going to now split it in 2. And this is, it's still going to be quite a complicated drawing because of the repetitive Fibonacci sequence being pulled into it. Spare. This would be fib of 5, would give us fib of 4 plus fib of 3. This would give us a fib of 3 plus a fib of 2. This would give us a fib of 2 plus a fib of 1. This would give us a fib of 1, which we know is 1. And fib of 1 is also 1. Okay. Now the fib of 3, 2 give us fib of 2 plus fib of 1 is 1. Let's just take this one away. Okay, but it doesn't answer what the fib of 2 is. Fib of 2 is 1, and fib of 0 and then we have a final one of fib of 1 is 1. I will go through the Fibonacci code now. As you can see, trying to draw this out is a bit more complicated than you would originally think. Because remember, we're making 2 recursive calls. But does everyone get the idea? As we move up, we're stacking at least. I don't want to confuse you guys too much today. We will answer some of these questions. I'll try to draw a better version of this later so you guys can see it. Okay. So if you look at the code, Fibonacci is just this. It's saying if n is 1 or n is 0, return n. So if it's 1 or 0, it returns 1 or 0. Done. Else it goes and calls the sequence for n of minus 1. And it keeps doing this until it reaches 1 or 0 and then returns 1 or 0 and builds back up. So the reason this one's a bit difficult to draw out is the fact that it's got 2 recursive calls. On that point, before I forget, direct and indirect. These are the types of recursions. So let's just say we have I'm going to do bad examples, but I need to do what I'm trying to illustrate. Return. I know this will break, just bear with me. I'm just showing you the difference between direct and indirect. Okay, private B. Actually, screw it, I don't need a parameter. Okay. So I'll come back to Fibonacci now. I just want to make sure I have covered direct, indirect. This is an example of direct recursion, where a function is calling itself. I know I'm missing a base case in recursive call. I'm aware of that. But what I want you to point out is function A is calling function A. That is a direct recursion. Indirect recursion is function B is calling C, C is calling B. So we have indirect recursion. You're not going to be, and the session's ending and has technically ended. So you're not going to have this situation often, but it can occur. So this is indirect recursion, where one function calls another function, that function calls a previous function, resulting in a consistently indirect recursion. This is direct recursion. This is the Fibonacci. If you guys have questions, this afternoon's TUT will handle it. Next week's TUTs will also be focused on recursion as well, so don't worry. But the lecture ended a few minutes ago. I don't know if you guys have class after this. I don't want to keep you on for much longer either. So any last minute questions, please ask them, or start thinking of questions for the TUT this afternoon. The TUT can be related to practical or recursion. I'll try to find an example that uses indirect recursion. Yeah. I'll probably make a note of that. There's no lecture on Friday. It's just a talk. There's just practicals. We have another tutorial this afternoon at 1 o'clock. If I'm not reading them wrong, the next tutorial is at 1 o'clock this afternoon. No lecture on a Friday, just a practical session in the afternoon. So please, if you haven't booked yet, please book for your practical session. I'll some auto allocating. Okay, that's it for today's lecture, ladies and gentlemen. We will have the TUT this afternoon. And any questions you have, you can pop them there as well. But next week's tutorials will focus on recursion as well, so don't worry. We're not leaving you guys in the lurch. We're just doing, unfortunately, these 45-minute sessions aren't long enough to discuss everything smoothly.